All right, let's see how you did on your assignment yesterday, understanding these p-value, the p-value interpretation, and your two-tailed test. So here we have this first statement where you have really three parts to that p-value interpretation. Okay, remember it is the one part is that you are the p-value is the probability. Okay, and then the second part is you talk about this sample or something more extreme. Okay, so it's the probability that you get those sample results that you got. Okay, if the data is anchored around where the null hypothesis is, if the claim is true. Okay, so we have the tricky thing sometimes is putting it in context. So this one, of course, with a p-value of 0.031, so that's a 3.1% chance. Okay, and we want to talk about getting this sample. So of getting 32 or more extreme. 32, so how did I know or more? Well, it had to do with the fact that the alternative was a greater than. So because we were seeing if the new treatment is more effective than the old, then so the probability of getting 32 or more patients out of the 70 and context who do what? Who have relief from the itchiness of poison ivy. Okay, so 3.1% chance of getting these sample results of 32 or more patients of the 70 having relief from itchiness of the poison ivy. If the data is centered such that if we say the new ointment has the same effectiveness as the old ointment, then there was a 3.1% chance of getting those sample results. Okay, so that's what's going on here. So in fact, you could start your p-value interpretation with the last thing. If seatbelt use today is the same as seatbelt use was 3 years ago, that's what the null hypothesis says, then there was a 17% chance of getting a sample that showed 86 or more drivers out of the 102 traffic stops who wore their seatbelt. Okay, so there's the sample that we got or more. Okay, now this one is talking about being significant. So if we're talking about being significant, then we're addressing where our sample is located. So let me demonstrate this little sample. So we are told that, here's my sample. Let's talk about where it's placed. We are told that he made this decision of a significant difference or a significantly better on an alpha of 0.05. That means that this sample is somewhere in this blue section of 0.05. Okay, significant at the 0.05 level. That's why alpha is sometimes called significance level, because that's the level that you need to be smaller than to be considered statistically significant results. All right, now the question is, would he have made the same decision to reject the null hypothesis at the 10% level? Well, that means if I'm so you can imagine if my sample is in the blue area, then yes, it is definitely going to be in the red area. So, and that's what I have written here in this second statement. If the sample is in the top 5%, then of course it's in the top 10%. So yes, it will be significant at the 10% level as well. But what about at the 1% level? Well, if our sample was in the green section, then it would be significant. And if it was in the green section, it was also in the blue and also in the red. But there is this area that this sample could have been placed right here, where it was not quite in the top 1%, and therefore it would not have been significant at that level. So if the sample is in the top 5%, is it in the top 1%? Maybe, maybe not. So not necessarily. Therefore, we do not know if the sample is significant at the 1% level. I don't know why that got left off, at the 1% level. Okay? All right, so there's what's going on with that. So now let's talk about doing our phantoms with TwoTail and how that looks. So, oh, here was another one. Sorry. Here's so here's about measles vaccination. If the measles vaccination rate today is what health officials claimed, so that was what the null hypothesis said. If the measles vaccination rate is 90%, then there was only a 1.1% chance that we would have gotten the sample results we got. So, of getting a sample showing 89.4% or less children vaccinated against the measles. See, or less is because we think that it could be less, the proportion of children getting vaccinated could be going down. All right, so that's the more extreme direction. So here comes our two-tailed test. One thing to note, see this 4% level of significance? That is your alpha. So that's another name for your size of your rejection region. So here we go. This was about P equals the proportion of men who have an inaccurate estimate for their percent body fat. So we were seeing, so why did I choose this to be two-tailed? Well, do these findings indicate that the knowledge of a person's body fat has changed? That question that I'm investigating is what led me to choose a not equal to sign as the alternative. Okay? So now here were my conditions. Making sure that here your 80 times 0.62, the true P, all right, and the approximately normal is a 1 proportion z-test. So when I get this z-score that I got, so the p-hat minus the p over the standard deviation, I got negative 1.48. So if we think about it, here's what's happening. I get a z-score down here. So I calculate the p-value of this tail by going to the more extreme direction, which the more extreme of that direction is lower. So the one tail of the p-value would be negative 99 to negative 1.48. But the p-value has two tails. So that means I then account for this duplicate area up here and multiply that by 2. So my total p-value is 0.138. And that, of course, is greater than our significance level of 0.04, so I fail to reject. Since the p-value is greater than alpha, I fail to reject. There is not evidence. So if I don't reject, then I did not have evidence of HA. There is not evidence that the proportion of men who have an inaccurate estimate of their percent body fat has changed. Or you could say is different than 62%. Okay, when I used that question, or the answer to the question has changed, then that was specifically referencing the question they asked. So I see I did answer that, and so there that was. All right, now this page I'm actually going to discuss in a separate video. So kind of like even a notes video for this lesson today. So I'll go ahead and stop this at this point, and I will see you in the next video.